So we go to Chicago here with Jesper from Buga, coming all the way from Berlin, Germany.
Yep.
Steve coming all the way from the East Coast, from Boston.
Yes.
Or actually, you're coming from a customer side in Europe.
Right.
Steve from Basho. So you're both giving talks here. I'm very happy you're here, of course.
Thank you.
So I just saw Jesper's talk, and I really loved that you went through like some large-scale deployments and issues and other problems that you had and all the mistakes you made along the way. And I just have to say, I really love those kinds of talks. They're not giving enough credit, because there's a nice flashy talks about from vendors that will explain how their product will rule the world.
Well, I'll have to talk as well. It's goes over a series of steps you take to get your system to where it is today. And your system isn't just one way of doing things. You showed about 6 different games and how they're different.
Some of them are using React.
Some use React. You like that. Some are Erlang, some are Ruby, some are JRuby.
Yeah.
More talks like that.
We'll try to do that. And your talk is tomorrow?
My talk's tomorrow. It's going to talk about Erlang and React, so how we, what we benefit from in terms of Erlang and implementing React, the challenges we face from Erlang in implementing React. So talks about Erlang, talks about React, doesn't go into a deep dive into either one of them.
But I've already bookmarked it, so I'll go with that.
Oh, good.
Yeah, so I find it. So there's lots of things that we could talk about. I don't know. One thing is, it's interesting that you go to these conferences like these, and you always hear about these big flashy deployments of like super large scale systems. And at the end of the day, when most people come home from here, their systems are probably not as large as yours or as some of your deployments. Mm-hmm. So maybe they don't need all this fancy stuff.
Well, Dan North talked today.
Yes.
Sort of along those lines. He was saying how we have all these patterns that people say you should use this and this and this, and factories and all these techniques that kind of keep making things bigger and bigger when a lot of systems just don't need that level of complexity.
He also said something that our job is to build solutions. So in the end, we need to have something that we can ship, and someone out there wants to use that. If we build some fantastic piece of technology and no one wants to use it, what's the value of that? Nothing. It's an academic exercise.
It's fun to build.
Yeah, it's fun to build, and that's cool, but we are paid for that, and as a professional, I think we are well paid usually. So where's the value of that? We need to have something that someone out there really wants to use, so that we get the money back that we earn. I think that's our job in the end.
Yeah, I think having talks at conferences like this about some of these larger systems is, educational for a lot of the attendees. Their systems today may not need to scale in the way some of these systems do. They may never get to that scale, but some of them will. Things that we assume today are big systems, in 5 or 10 years they will be average systems. So it's nice to know that the techniques were described, even if in 5 or 10 years we find better ways of doing it, that some of the techniques we use today may not be used at that point. It's nice to have those talks captured, as you do on video and everything, so that developers are aware of the techniques. But they should never get the impression that just because Wuga or other kind of large-scale systems use these techniques, that's the only way to go, that they have to use those techniques.
So one of the things I think the two of you also have in common here is that you talked a lot about operations and how developers are engaged in operations. And the hard part of building a system is really managing the databases, managing the data.
Yes.
And I think that's also very much the message in kind of the purpose for React, is to make managing data simple. So maybe you can talk a bit about that. So maybe you could, you had some really good points in your talk.
So the one thing that we noticed over and over, so we did have many games that we did. For each game it's a different team, and that team comes up with their own decision, own architecture. And it always boils down to the same thing. How do you handle the state of the players of our games, which can be huge, because we have many millions of players. And it's much harder to fix something in your software later on than fixing something in your data layer. I'm not talking about accessing the data, but actually migrating data from one database system to another because you did a wrong storage, or to update your sharding. This is really hard, tough, takes weeks to migrate the data on demand, to check it that it runs, and also the effort in upfront testing is huge because coming back to what Chili's talk, if you make a mistake in the migration, you update the state to wrong value and you erase everything. You erase the value of your product.
Well, so that's why you want DBAs and only using Oracle and only using kind of solid backend technologies that you know you can manage.
If you want to ship a new version every 3 months, that might be a good option. But probably if you do that, competition runs circles around you because you're just moving too slow. That's the thing. So the thing is to find a good compromise on low operational overhead and still the ability to innovate your product fast enough to ship new version every day or every week. And this is where we are described.
Yeah. Well, React's a good example, I think, of both topics we've touched on. It's simple compared to a relational system or some of the other databases out there. The data model is quite simple. Key value, we can do secondary indexes and full text search, but primarily key value, some map reduce. But so that's, a lot of people say, well, I need relational database, and it kind of goes back to what Dan said, which is, do you really need a relational database, or are you doing that just because everyone else uses a relational database? So you look at your application, look at the solution you're trying to provide. In a lot of cases, a key value store fits the problem really well, lets you provide a solution for a lot less expense than with an Oracle or that sort of system. And then the operation side, you've now deployed your solution, and that's where you're making your money. That's how you're solving your customer problems. And if you need an army of DBAs to take care of the system, you're paying a lot of money for that. And making something operationally simple allows you to be more agile, allows you to be able to have a new solution every week, try something new. You don't have to have that bureaucracy of working through some special IT group that controls the database and only allows certain changes to it. Yeah. So with React's operational simplicity, you have a lot more flexibility.
The thing is, if you have development on one side and people who operate the system on the other side, the people on the development side, they want to push a new feature because this is what they basically paid for. And the guys on the operation side, they want to restrict change, they want to reduce risk to the live system because they are paid for making no mistakes. And there's a gap and a clash in between. And this is, I think, where the whole DevOps movement comes from, to combine these two. And this is why I like a system that I can just operate. The same person can develop and operate the same system. So that means that the guy who did the architecture decisions, they implement the feature, they also have to operate that thing. And if something bad turns out, you have that feedback circle. And that's very powerful. So you need a system that runs this low operational overhead.
So how do you do that at VUCA? How do you make the developers actually run operations?
We just tell them up front, so we first ask them, how do you want to build your system? Starting with, which data center do you want to host that stuff? Do you want to get bare metal or to cloud? And all the time when they are developing and designing a system, they know if something goes wrong in the middle of the night, they get the text message and then they got caught up in the middle of the night. So this influences the architecture decisions. So while they have freedom to do all the fancy stuff and all the new things, they know that it will be them standing up in the middle of the night, and that's a very good counterbalance. And the one drawback is that you have to very broad knowledge. It's not enough to just develop software. But actually, I think that is a good thing. If you just develop software and have no clue about what it does in operation, you probably will not develop software that can be operated easily. So having it both in one function actually is a good thing, and people in our teams, they have enough time to prepare because it takes 6 months or a year to develop a game, so they have time to prepare, and there's a lot of knowledge exchange between the teams. So we help each other out, basically.
So how about in terms of React, what size system do you need for it to make sense to run React? What's the is there like a lower limit?
Well, yeah. I mean,
When do you say no? This doesn't make sense because this is too small or too simple.
Well, there are customers that come to the React users mailing list, and they'll say, "I've been testing React on this single node, and it seems to be slower than this other solution. Why is that?" And you have to explain to them that it's built for availability. It's built to run on a cluster of machines. So when you're running it on a single node, it's writing by default 3 copies of everything you write to it. So your one disk is quite busy servicing those 3 copies. So the minimum number of machines that we recommend is 5. And that's basically due to, even if you had 3 machines, you're still keeping all of those busy. And if you have a failure of any machine or a network partition that takes out a machine, then the remaining 2 would be extremely busy. So 5 is a nice, good number, that allows you to have the operation continue with, reasonable latency and predictable latency, even if there are failures of one of the machines or even 2 of the machines.
So your focus really is on availability.
Yes.
I mean that's the first feature. Availability first.
Availability first, mostly.
Mostly.
The reason I say mostly is we're also working in the background on stronger consistency features. There are cases where customers want the option of saying, for this bucket of data, I want strong consistency.
Mm-hmm.
And so that's something we're going to work on. Will come out in a future version of React. But today's React really is primarily about availability, and when a machine dies or the network partitions, you can still read and write data.
And do something reasonable.
Something reasonable.
An average customer would probably just say it needs to be highly available and performant, and be super good, secure. You can add all these fancy terms.
Yeah. Customers want everything, basically,
Always.
and you have to work with them to understand their application to figure out what they really need, because everything is costly. It costs a lot to get everything.
It's always a trade-off, right?
Yeah.
Availability is a trade-off, speed is a trade-off, flexibility is a trade-off.
And even, they may need at some point in the future some high-scale, high-performance, highly available system, but they usually don't need it right away. They can iterate up to that point. So you have to work with them to understand where they are today and where they need to be.
I think it's also completely different what type of application you are using. I mean, if you're shooting a robot to Mars, you will probably not be able to fix anything while it's there. They do that, but it's amazing that they can do so. You need a really low threshold of error and everything. So it's okay. I mean, doing such a program takes 20 years, so you have time to do that. And for bank application, also you never want to lose money if the banking application is down. For a large bank, probably after a day it's bankrupt. For a game, we can live with a downtime of 10 minutes. That's not so bad. So it's really different depending on its use cases.
Actually, interesting note on the spacecraft side. With all the spacecraft that go to Mars, like with, I think, the most recent landers being an example, the software was actually nowhere near done when the thing launched. And they would upload firmware en route. So they had an extra year and a half or 8 months or whatever it was to fill in a lot of that data. So they'd have the initial firmware, which did the cruise software, and then as it came into Mars, they would replace it with lander software, and then once it landed, they replace that with surface software. So ongoing upgrade, you can't change the hardware.
That's a really interesting trend because, it's kind of like the NASA and other large corporations. They are learning from the software industry, and maybe it's a good idea to have some flexibility. I mean, when you look at what these small robots they're done and how they fix situations, that's operational practice. So the thing to make operation successful basically is very simple. Know what is really going on in the system and then have the means to fix it. So if it's some gigantic black box, coming back to the Oracle example, like if you really have a problem, what do? Call Oracle at 2,000 euros a day consulting cost or whatever, and how long does this take? So if the system underlying is simple and it's also transparent, which is one of the reasons why we're so happy with Real, is that you can really understand what's going on there and you can try fixing things or have a very responsive mailing list. Whereas when you have a black box thing, usually it works, but when it's not, you have a problem.
So you've also picked up Erlang for some of your systems.
Mm-hmm.
So what's your experience with that?
In the beginning, very frightening.
Very frightening?
Yeah, when the first guy came to us and was like, we have this problem, and the way how we do stateless service, this is not the right thing. We need something stateful. And that's frightening in operation sense, because suddenly in operation so it becomes some very expensive commodity. And out of this making stateful came the thing, okay, now we need a different programming language and framework to build this, and this is how we ended up in OTP. So we didn't want to try out Erlang, but actually wanted to have something extremely robust. But still it was very frightening because no one in the company knew Erlang, and actually we had an extremely hard time to find anyone who had experience with that. So there was no user group where you could just go to for some people. But when we started doing this, we were surprised how easy some things became that before that were so hard to do. Also for me, I was coming from Java and then from Ruby, I was thinking, oh my god, and I really had a hard time figuring out where the comma goes and the dot goes and this kind of things, so very simplistic things. But after, I don't know, a month or so, I was really amazed how productive I was. Because the OTP framework was accessing exactly or addressing exactly the problem we are facing. And with just 10 lines of code, we could do amazing things because it was just the right fit for the kind of problems we were facing. So very hard, very frightening in the beginning, and then it was just.
But isn't that the same thing picking up Ruby on Rails?
I think that might be the other way. At the beginning it's so nice, and when you dig into the problems, then you get like what answer, you get the stack with 47 lines. So when you have a problem on Rails, it's very hard to find the root cause. And I think it's exactly the other way around in Erlang. So I think Ruby and Erlang, they're kind of like opposite twins. Ruby is very nice to program, but in operation it's hell, and Erlang is the other way around. So and this is why we mix these two. So right now we do systems that need to scale, and operation we tend to do in Erlang. But lots of the infrastructure scripting, using Chef for example, small things, ad hoc stuff, rapid prototyping to find out what the API should look like, we tend to do that in Ruby. And I think this is a great combination.
I think OTP is a good example. The Open Telecom Platform part of Erlang is a good example of what we've been talking about in terms of building what you need. Because the Ericsson teams that built OTP were actually building a product when they built OTP. They didn't sit down and say, gee, we need a framework that's highly robust and has all these failover features and allow all this debuggability and logging. And, I don't know what we would have ended up with if that had been their approach. But they were building a switch, and they knew what they needed based on their many years of experience in doing that. So OTP grew out of applying their knowledge of how these systems were deployed, debugged, maintained, upgraded, and they built those features, and just those features, into OTP. And one of the points I'll make in my talk tomorrow is that when you're dealing with Erlang programmers, nobody goes off and tries to reinvent OTP. They just use OTP. So any Erlang program or system that you go and look at, you can, pretty much any Erlang programmer can go and read the system because it's all composed of those same frameworks. There's no reinvention of the wheel. Very nice.
I think also Erlang, so at Vuga we have kind of like people come from different backgrounds, and I can experience firsthand the Ruby community and now the Erlang community, which is also in Berlin growing, so we have been working in Erlang user group. I mean, half of the people come from Google, but that website, there's a community growing. And it's a different value system. Sometimes these clash. So with Ruby, it's more like this, keep it simple and really get to do it with less code and start very simple and iterate and just push it out of the door, ship it, get feedback, and then improve. And with Erlang, I noticed that it's more like, a bit more like thinking ahead. So what really is the underlying core problem that we're trying to solve? It's a distributed system. How do we manage state across nodes? What are the edge cases? So there's a bit more upfront thinking. And sometimes they clash. We have these architecture discussions, and sometimes, you can see like, okay, this is one school of programming, this is another school of programming. Both make good software, both one, but it's different. But combining the two is really powerful.
So what are you going to see here in Chicago this time? Or what? Maybe what talks you went to today? I don't know.
Today I went to Jesper's talk, which, as we've discussed, was very good. I'm going to see John Alspa's talk tomorrow, because John is very much from this DevOps background, and I could listen to John all day long. Let's see. I don't know. How about Jim?
So John's talk is a must go from me. Also your talk. And for me, the guy, the talk by Bjorn this morning from the Relic, because I really wished like I would have had these insights from years ago, because he had come with the same theme. It was like recognizing exactly what kind of system you're building. So they started very small, similar to us, and then they recognized the kind of system. Then they did all sorts of fancy, very specialized optimizations. And that's also the same conclusion that we came to. So that sometimes it's really not like pick the best tool, what did other people do, but actually what is your use case, and then fix that. So I really like that talk. Also, it was very technical and specific, but I just wished I had it 4 years ago.
That's actually an interesting question. Do you think that that's a common issue that we encounter in software, is that when you're building an application, when you're building a solution, sometimes you don't necessarily know what the problem is you're trying to solve. You're just building something because you think it's cool. I wonder how much of that actually knowing what the core problem is and being able to address it accurately, or not being able to do that causes it.
Well, it's definitely been the case for much of the last 10, 15 years that whatever you build, you start with J2E.
Yes. Oh, yes.
And a relational database.
Yeah, and Oracle.
Yeah.
Yeah, almost.
Yeah. I think sometimes people think they know what they're building, and they build it, and then they realize after having built an early version that they don't really understand what they're building. And certainly with Riak, Andy Gross is here, chief architect of Basho, and he gave a talk just before this interview about kind of the evolution of Riak, and that's really what happened to Basho, is they built things into Riak that they thought would work well, like active anti-entropy. The early versions didn't work very well. They were meant to make the database reach consistency faster, but they didn't work very well, so we took them out. And then once we figured out how to really do it, they're back in. So that's back in the system now. But that's another reason, again, going back to what Dan talked about, keep it simple. You don't have to buy into all these frameworks and everything up front. Figure out what you're going to build, and then don't be afraid to throw a system away and build another one. And that's why with Erlang, it's so easy to do that, because you don't get invested in millions of lines of code. You get invested in thousands, maybe, lines of code, and you feel it's easier to throw away a smaller system.
It's interesting. That reminds me of a discussion I've had with a fellow who does a lot of .NET development. And one of his comments after doing years of .NET development coming over to Java is there's a lot of ways of doing the same thing in Java, and oftentimes in .NET there's really only one way to do it. And it seems like there's a similar thing with Erlang, like with OTP, where there's this particular framework that everybody tends to use. Do you think that's a strength of Erlang? Is that something that if more of these things were standardized in Java, that it would make it easier to develop in, or is Java lost cause? Your thoughts?
Is Java a lost cause? I've never liked Java, personally.
I used Java for some years, and yes, it was always these J2E or JEE applications, and always the same. Coming before the Java, I was in the Microsoft space, and coming to Java, it was like breaking out of a cage, because the only information source before was MSDN, the Microsoft Development Network, and that was basically the only thing. And in Java, it was like open space. You have this notion, I think different developer communities value different things. So for example, when you look at Python, there's also like, this is the best way of doing things, similar to Erlang. Whereas in Ruby, it's kind of like there are these 15 ways of doing things, more to like Java. I think it boils down to personal taste. Having too many things might hurt, but I think this is one of these philosophical, whatever, please cut that out. So this is one of the things where you can have endless discussions without really coming to a solution. But having, I think the thing with Erlang OTP is not like, this is the one day you have to do it. It's just like, it's such a really good way to do things. So deviating from that is just not necessary. I think this is more like the strength of Erlang OTP.
Yeah, I mean, I've said before in other talks and interviews that when I finally found Erlang, it was kind of a happy and sad occasion, because I was happy to have found such a really useful system. It's sad that I'd spent so many years trying to invent that system and not doing so well at inventing it. So yeah, I'm happy that I can use it now.
Okay, thank you very much. I think we'll end here.
Thank you.